All right, welcome back everyone to the deep dive. Today we're going to be talking about building classes, which is really a fundamental concept in object-oriented programming. Think of it like a blueprint. Like
Yeah.
how do you create an object? And one of the most common examples that's always used is this idea of an employee class. And for all of you out there who are preparing for senior level technical interviews, this is something that you really need to understand inside and out, especially as you get into system design and architectural conversations.
Yeah, absolutely. We're going to be diving into an example of an employee object, and it's got a couple of different attributes. It has a name, which for this example, we're going to say that name can't change once it's set. And then it also has a salary, which we will allow to change. And so the point of this deep dive is really to understand how to actually define a class. And we're going to focus on instance variables and methods, because those are the kinds of things that you see all the time in these senior level technical interview questions.
Okay, so let's build out this idea of an employee.
Right.
We've got this employee object, and we're saying that there's a name and a salary. So in programming, and specifically in a language like Java, we use these things called instance variables to store this information. So for our employee class, we would have something like private string name and then private double salary to store those pieces of information. But what exactly are these instance variables doing? What's their role?
Yeah, so these instance variables are really responsible for holding the state of each object. So if you think about it, like you've got a team of employees, each one is going to have a different name. They're all going to have presumably a different salary. And so that information is stored within each employee object using these instance variables. And you said private there, which is a really important point.
Yeah, I've seen private used a lot with instance variables. Yeah, I know it's all about restricting access, but
Mm.
can you dive a little bit deeper into why that's such a common practice? What's the thinking behind that?
Yeah, so the main benefit of making these instance variables private is it really gives you a lot of control over how that data is modified. It's not even just to prevent like accidents from happening. It's really just to make sure that the object is in a valid state all the time. You don't want just any part of your system to be able to like go in and change someone's salary without going through some sort of like, well-defined process.
Yeah, that makes sense from a data integrity perspective, so
Yeah.
checks and balances. But I feel like there's got to be something more to it, though.
Right. So think about it this way. So by making the internal representation, right? So like the actual name and salary variables, by making those private, what we're doing is we're saying, hey, look, we are going to interact with these employee objects through these public methods, right? So as long as those public methods are working correctly and they're taking the right inputs and giving the right outputs, we could completely change how the employee is actually storing that data internally.
So, like, if we started off just storing the name and salary directly, but maybe later on we decide, hey, we need to pull this information from a database instead.
Yeah, exactly. So if those variables were public, then a lot of your other code might be like accessing those directly. And then if you had to change it to use a database, you'd have to go and rewrite all that code. But if we make those private and we just expose these public methods like get name and raise salary, then we can change the internal storage mechanism and maybe even use like a database ID to store the data instead of the actual name and salary. And as long as those public methods keep working the same, nothing else in the system even has to know that we made that change.
I see. Okay, so we're talking about levels of abstraction here. We're hiding the implementation details and we're presenting this stable interface to interact with these employee objects.
Hmm.
So it's not just about protecting the data. It's also about future-proofing the code, making it more adaptable. And especially as systems get larger and more complex, that becomes more and more important.
Exactly, yeah. And being able to change that internal implementation without affecting other parts of your program, that's really a hallmark of a well-designed, maintainable system.
Yeah.
And it's the kind of thinking that you really want to be doing as a senior engineer.
That's a really good point. So I've got our instance variables, that's the data. But how do we actually do anything with these employee objects? How do
Yeah.
we interact with that data? That's where methods come into play, right? And the first thing we need to understand is this idea of a method header. What exactly is a method header?
Yeah, so the method header is it's basically the signature of a method. Like if you think about it like a contract, it's telling anyone that wants to use this method what information they need to give it and what they're going to get back in return. And so it includes the name of the method, the types and names of any parameters that it takes, and also the type of value it returns. And if it doesn't return anything, then it's void.
Right, like, our example, we have this method header that's public void raise salary, double by percent. And I guess, let's break down what that's actually saying here. So a public that's telling us who can call this method.
Yeah,
Right.
exactly. So public means that this method can be called from anywhere in our program. And then next we have void. What does void tell someone using this method?
So void basically means that it's not going to return any value. It's just going to execute. It's going to do something, but then it doesn't send anything back.
Hmm.
And then we have raise salary, which is obviously the name of the method. So that's pretty clear what it's supposed to do. And then in the parentheses, we have double by percent, which is saying that, when you call this method, you need to give it some information. You need to give it a number, specifically of type double. And that's going to be used, within the method, and it's going to be referred to as by percent.
Exactly. And the other example we have is public string get name. What do you think that method header means?
Okay, so public, again, that's accessible from anywhere. String, that means it's going to return something of type string. So presumably in this case, it's going to return the employee's name. Uh, that's the name of the method, so that makes sense. And then the empty parentheses that's saying, hey, this doesn't need any information, to actually do its job.
Precisely. Yeah, and just like instance variables, methods can also have access modifiers. So we've been talking about public, but the source also mentions private methods. What do you think a private method would be used for?
So if we're following the analogy with private instance variables, I guess that means that a private method would be something that's used internally within the employee class itself. It's not something that other parts of the code can call directly. Maybe like a helper function to do some specific calculation that's only needed by other methods within the employee class.
Yeah, spot on. Private methods are basically helper functions. They're for internal logic, implementation details. And again, the big advantage here, just like with private instance variables, is that you can change them or even remove them later on if you need to. Maybe you're refactoring your code or changing how the employee works internally. Because they're private, they're not part of the public contract of the class. And so, if you make those changes, it's not going to break any other parts of your program that are interacting with these employee objects through those public methods. So again, it's just like, really good encapsulation, well-defined boundaries, which again, when you're dealing with these large systems, that becomes really, really critical.
Makes sense. So the method header tells us how we can interact with an object. What happens when we actually call one of these methods? That takes us to the method body, right?
Exactly. That's where all the actual steps, the implementation details go. So the method body contains the statements that actually get executed when the method is called. So for example, here's the method body for that raise salary example that we were talking about.
Oh, yeah. Okay, so it's this. Java, double raise, salary by percent 100, salary plus equals raise. How does this actually work when it's called?
Right. So let's say you call the raise salary method on a specific employee object and you give it, 5 is the percent raise. So that value of 5 is going to be assigned to that by percent parameter. So the first line inside the method, it says double raise salary by percent 100. What that's doing is it's calculating the actual raise amount, right? So it's taking the current salary of that employee object, multiplying it by that by percent that you passed in, which in this case is 5, and then dividing by 100 to get the actual raise amount. And then it's storing that in a new variable called raise.
And then the next line, salary plus is raise. That's taking that calculated raise amount and it's adding it to the salary instance variable of that employee object, so it's updating their salary.
Exactly. So this is showing how methods can actually operate on and modify the internal state of an object, those instance variables that we were talking about. Now let's look at the body of the getName method, which is a bit simpler. It's just the return name. So what's happening there?
Okay, so here the keyword return is important. What it's doing is it's sending back a value to whatever part of the program called this getName method. So in this case, it's just returning the current value of that name instance variable for that employee object.
Yeah, exactly. So the methods, that's where you put the behaviors of your objects, and the method body, that's where you actually implement those behaviors. So understanding how these methods work and how they manipulate the object's data, that's really key to understanding object-oriented programming.
Perfect. So we've got our employee class, it's got its instance variables, it's got its methods. How do we actually use this in practice? How do we use these methods with a real employee object? The source material talks about this idea of instance method invocations.
Right. So the way you actually make an employee object do something is you first have to create an instance of that class, right? So let's say you've created an employee object and you've given it the variable name Fred. So to give Fred a 5% raise, you would call the raise salary method on that Fred object. So you would say Fred dot raise salary 5.
So Fred in this case is like a specific employee that we've created, and then the 5 that we're passing in, that's like the actual, 5% raise that we're giving to Fred, right?
Exactly. And so when that raise salary method is called on that Fred object, that 5 is going to be used to initialize the by percent variable. And then when that line double raise its Fred.salary by percent 100 is executed, it's going to be using Fred's salary in that calculation. And then finally, when the line Fred salary plus is return unit, it's going to be updating Fred's salary.
So it's important to understand that each individual employee object has its own set of instance variables. So like Fred has his own name, Fred has his own salary. When we call a method on Fred, it's operating on Fred's data. It's not like there's one shared salary variable for all employees.
Precisely. And that's the big difference between what are called instance methods, which operate on specific instances of a class, and static methods, which the source mentioned briefly. But those are different. They're often associated with the class itself rather than individual objects. Instance methods, though, those are really like the workhorses of object-oriented programming because they allow you to define the unique behaviors of individual objects and how they interact with their own data.
Now, there was also this kind of subtle point in the source material about an implicit parameter being passed when we call an instance method. Can you talk a little more about that?
Yeah, that's a little bit more of a technical detail, but it's really an important one. So when you call an instance method on an object, like in our example, Fred.raise salary 5, the method is actually implicitly receiving a reference to that specific object, to Fred in this case, and it's using that reference to know which employee object's salary it should be working with. So, it's not something that we see explicitly in the code. It's not in the methods parameters, but it's happening under the hood. And understanding this like fundamental aspect of how methods and objects interact, I think it can be really helpful when you start getting into like more complex object-oriented programming scenarios, maybe when you're debugging something tricky. And I think that's the kind of thing that can really help you stand out in those senior level technical discussions.
So this has been a really great deep dive into this whole process of building classes. And we use this employee example. We talked about how instance variables define the state of an object and why it's so important to make them private, for encapsulation and for making our code more maintainable. We looked at method headers. That's like the contract for how we interact with these objects. We saw the method body. That's where the implementation details live. And then finally, we talked about instance method invocation, which is just a fancy way of saying calling a method on a specific object and how these methods actually operate on that object's data.
Absolutely. And I think, mastering these basic concepts, it's really the foundation for building more sophisticated object-oriented designs and architectures. And for anyone out there preparing for senior level roles, having a solid understanding of these principles, it's really non-negotiable.
So to wrap things up, for those of you who are getting ready for your senior technical interviews, here's a final thought for you to consider. We've been talking about these principles of encapsulation and abstraction using this, simple employee example. But think about how those same ideas, the idea of protecting data and providing these clear interfaces through methods, think about how those same ideas scale up to much larger, more complex systems. And, when you go into an interview, especially when you're talking about system design or like high-level code architecture, think about how you would explain these concepts. How do these fundamental building blocks that we talk about, how do they enable us to create robust, scalable, maintainable software? The kind of systems that senior engineers are expected to design and build. I think that's really the level of understanding that sets candidates apart at that senior level. Anyway, that's all we've got for you today. Thanks for joining us for the deep dive.